Hey class, so today we're going to work on square roots. We're starting unit 4. Okay, so a square root is the inverse operation of a power. Sorry. It determines the base of a power that has been squared. There are also cubed roots. That's when you see this little 3. And there's fourth roots, okay, etc. Okay? If you don't see anything, it's assumed that it's the squared and they're not going to put the 2 there. Okay? If there's nothing there, it's assumed that it's squared. Okay. So, the square root of 25, or the image square root of 25, equals 5. Now, in your calculator, let's see if I can pull this up. I don't know if... Okay, it does have it. Okay, so here's the squared root button. So 25, and then take the square root of that. Your answer is 5. Okay? So that's why we have that. Or the answer could also be -5. Okay? Because this just means that 5 times 5 equals 25, but also the same with the negative, okay? -5 times -5 equals 25, okay? So usually this is written as the square root of 25 equals, and then you could say the plus or minus 5. Okay, so important facts. The number 5 and -5 are called the roots of 25. This symbol right here is called a radical and represents the square root of a non-negative number. So let's do some examples. Okay, so calculate each square root. So in your calculator, the first one, square root of 9. Okay, so this is a cheap calculator online, so I have to do it backwards. So I'd put 9 and then square root, and the answer is 3. On the nice fancy calculators, you would hit the square root button first, and then you would actually see the image of a square root, and then you would hit the number 9 and then hit equals. Okay, so everyone's different. Okay, for the second one, just ignore this. I could not get rid of that for some reason. So anyways, the square root of 144, so on this computer one, 144, and then take the square, 144 and take the square root, your answer is 12. The square root here, the square root of 9, sorry, I don't know why I just drew that on there. Okay, so the square root of 9, you can do that one first in your calculator. Okay, so we know the square root of 9 is 3. Okay, so it's going to be 3 over, and then you do the square root of 16. The square root of 16 is 4. So the answer is 3/4, 3 over 4. Okay, next one. So see, it's a negative underneath the square root. Okay, so watch what happens when you do this. 64 negative, okay, and then take the square root, invalid input, or sometimes it might say error. Okay, so you cannot take the square root of a negative number. Okay, so same thing right here. Because I see the negative in there, I don't even have to put it in my calculator. Just write down error. Okay, now this on the other hand is different. The negative is out in front. Okay, so our answer is going to be negative, and now we just focus on the square root of 4. So in your calculator, 4 square root is 2. So the answer is -2. So down here it says, what's the square root of a negative number? Okay, so the answer is just error. Okay, that's imaginary numbers. Okay, you cannot take the square root of a negative number. Next, the radical symbol works like brackets. If there is an expression within the radical, remember, and this is the radical, so if there's an expression in that radical, it has to be simplified before taking the square root. So for example, this right here, 16 plus 9, we have to do that first. So 16 plus 9 gives you 25. Now we can take the square root of 25. And in your calculator, 25 square root, your answer is 5. Next one, we have 48 divided by 3. Well, we have to figure out what 48 divided by 3 is first. 48 divided by 3 gives us 16. Now we can do the square root of 16, and our answer is 4. And next one, we have 13 squared first. So let's figure out what 13 times 13 is. 13 squared is 169. Okay? And now we have to take the square root of 169, take the square root, and your answer is 13. And that's kind of a trick question. If you see a squared sign under here and the square root sign, they actually just cancel with each other. And then your answer would be 13. Okay, next. In the same way, if two square roots are separated by an operation, the square roots have to be calculated individually and then added or subtracted or multiplied or divided. Okay, so with this one first, we have to take the square root of 36 first. So the square root of 36, you put in your calculator, you will get a, oops, that was supposed to be a 6. I don't know why I wrote 3. Okay, 6. Subtract the square root of 4 is 2. And now we can subtract 6 minus 2 gives us 4. Next one. Here we keep the negative out in front. Okay, so we have to figure out first what 24 divided by 6 is, right? So 24 divided by 6 gives us 4. Okay, and then we have to add the square root of 64. So square root 64 square root is 8. Okay, so now we have another step. We have to figure out what this, well, I guess square root of the 4. The negative just stays out in front. So square root of 4 is 2. And it's negative because this negative is out in front. And then we still have plus 8. And the answer here would be 6. Next one, square root of 1 divided by 4. So the first thing first is we have to do the square root of 1. Okay, so square root of 1 is kind of a trick question. 1 square root is 1. Okay, so that's easy. But then we have to do the square root of 4. Well, the square root of 4 is 2. Now we have to multiply it by the square root of 1. Okay, because this actually looks like this. Oh, man. Oops. It's supposed to be the erasing button. What the? Okay, so what this actually looks like is the square root of 1 divided by the square root of 25. And same thing for the first one too, okay? So square root of 1 is 1, square root of 25 is 5. Now, we have to multiply. So multiply the numerators together. 1 times 1 is 1. Multiply the denominators. 2 times 5 is 10. So your answer is 1/10. Okay, so now we're moving on to the Pythagorean Theorem. In a right-angled triangle, let me just see how much time we have left. Okay, we got time. In a right-angled triangle, the side with the longest length and the opposite, the right angle, is called, so this is what we're talking about. So when you have this square in the corner, you draw a line straight through, and that shows us the longest side, and it is called the hypotenuse. So right here, write hypotenuse. The other two sides are called the legs. According to the Pythagorean Theorem, in every right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the other two sides. Okay? So that's where this formula right here comes from. Okay? So we draw a line from the corner through the square, and it shows us our hypotenuse. Okay? So we have that, which they call C, which is where we had C right here. So capitals represent the angles, okay, so the corners. And then the small letters represent the sides. So you go opposite. So B, opposite that side, would be side little b, okay? Angle A across from it is side A, okay? So I like to refer to this as the hypotenuse. And then another option is I call it side 1 and side 2. So my formula, or another option of the formula, looks like this. The hypotenuse equals side 1 squared plus side 2 squared. So it doesn't matter whatever formula makes sense to you. Use that one. My only thing is that sometimes people get confused when they see the A, B's, and C's, because what if you had a triangle labeled like this? D, E, F. Okay? So that's my only thing. But if that doesn't bother you, then awesome. Okay? So down here, it says the formula can be arranged to calculate the length of any side of a right angled triangle if we know the lengths of the two other sides. So let's look here. It says calculate each missing length and round your answer to the nearest tenth of a unit, 1 decimal place when necessary, and show your calculations. So right away, what I do is I take my, or I look at my triangle and I draw my line out. Okay, and I call this my hypotenuse. Okay, and then I call this one side 1 and this one side 2. So I would do this. Hypotenuse squared equals side 1 squared plus side 2 squared. And then I fill them in. So my hypotenuse right here is C, so I call it C squared. I keep my equal signs lined up. My side 1 is 15. So it's 15 squared, and I keep my plus, and then my side 2 is 20. So it's 20 squared. Okay? So now we're going to do some simplifying. So C squared equals, so 15 squared, you put that in your calculator. So 15 squared gives us 225. So we have 225 plus, and then we have to figure out what 20 squared is. So 20 squared equals 400. So our next step here is we have to actually add these two numbers together. So we keep the C squared lined up, equal sign lined up, but now we're going to add 225 plus 400. So 400 plus 225, oh, that's not right. 400 plus 225, oh, sorry guys, 400 plus. Okay, anyways, 400 plus 225 is 625. It's kind of annoying doing it on here. It's not working properly. So then in order to solve for C, we have to do the opposite, which is the square root. And if you do it on one side, you have to do it to the other side. So I'm just going to continue over here just so I don't crowd out that other question. So the squared sign and square root sign cancel, and it just leaves you a C. But then the square root of 625, so 625 square root is 25. So the length of C is 25. And since we were dealing with meters, We put the little m there for meters. Okay, I'm going to finish this on the second video.